Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar today by thanking Spindance for sponsoring the event. Spindance is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is entitled How to Ensure IoT Product Success. Before we begin, I'd like to briefly review the format of today's proceedings. This event will be 1 hour long. We have one presenter who I'll introduce in just a moment, and there will be a Q&A session after the presentation. Feel free to ask questions at any time during the presentation using the questions feature in the control panel, and I will be asking the questions on your behalf during the Q&A portion of today's event. So now, I'm very pleased to introduce today's speaker. Jonathan Rand is the product owner at Spindance. So whenever you're ready, Jonathan, you can take it away.
Welcome, everyone. I am Jonathan Rand. I'm a product owner at Spindance. We are a software consulting company that specializes in IoT. We do embedded development, cloud development, mobile, and web. As a consulting firm, I get kind of the unique opportunity where even just in the last year, I've been part of 3 IoT platform development projects that support millions of connected devices. I also manage the product development for our proprietary IoT framework that Spindance offers as an accelerator to our custom development services. So I'm excited for the opportunity to share some of these experiences that I've had and some of the strategies to a broader audience. And I'm going to walk you through kind of the high level process that we go through with our clients and share some personal insights along the way. So the title of the webinar is How to Ensure IoT Products Succeed, but obviously there's no way that you can be absolutely sure. There's a lot of variables in connected products, but with the right planning, we can at least remove a lot of that risk. So there's some major hurdles with any product launch and some hurdles that are unique to IoT. So market reception, are your customers actually going to like what you build? The technology involved, the resourcing when you need firmware and embedded engineers and people with experience with serverless architecture and AWS or Azure. These are hard people to hire for, and they're in short supply and high demand. And then there's just the initial development costs as well as the ongoing costs of all the data storage, all of your telemetry, etc. So we start there, and now we need to figure out some ways where we can overcome all these things. So there's a few principles that I like to apply to any new product development. The first one is, does this solve a legitimate problem? That's the key to a consumer or even an industrial IoT, making sure that the product that you create is actually going to be valuable. And then the other one is that the technology gets out of the way. If you think about connected devices that have been really successful, it's usually because there's some really complex things happening in the background that make a very pleasant and simple interface for the user. So that's a big goal. And then looking towards opportunities for continuous improvement. This is kind of a major advantage of connected devices, is that your products can evolve over time with over-the-air updates. You can release new mobile apps that can interact with them in novel ways. And so from the onset, we want to be thinking about that continuous improvement. So I think all of this can be pretty simply summarized as build something that I can't live without. When you think about some of the favorite devices that you have, and some of the most successful that have ever been launched, it's because once people start to use these things, they can't imagine not having them anymore. So the first step to de-risk some of this is to first focus on the minimum viable product. And I can't emphasize this enough. It's so easy to lose sight of what's absolutely critical throughout the product development process. And there's going to be so many people with great ideas, but staying laser focused on exactly what's necessary in order to add that value to the end user and essentially release a product that works and does what its primary goal is crucial. And then the next one is just designing for flexibility. So thinking into the future and realizing that at some point in development, you're probably going to get new information that requires you to pivot. And a really well thought out system design can ensure that that need to pivot doesn't sink the project or put it over budget. And the final one is to consider how to take advantage of connectivity. So there's all this additional complexity that you have to deal with for connected products and cloud infrastructure, user interfaces, but at the same time, there's more value to connected products for the organizations that create them beyond what they give to an end user. So from the onset, we can plan to collect data for business intelligence operations to inform our roadmap and the future features based off of real data from our users. So that's kind of the wonderful thing about connected devices, is that they can evolve over time. So this is the high level process that we go through at Spindance when we engage with a client. And I'm going to try to walk you through what these steps might actually look like with a sample product. And we'll take like a slice of this and move through it. So first, we need a sample product. I remember more than a decade ago walking into a blue bottle coffee shop in San Francisco and ordering a coffee. And it was the first time I'd ever seen a pour over. And ever since, it's been a morning ritual of mine to hand grind the beans, heat the water to just the right temperature, and slowly brew a cup of coffee just the way I like it. The downside of this is that it takes 5 or 10 minutes just to make 1 cup of coffee. So if we can imagine a product that can simplify my life a little bit, and we're going to call the project Making the Drips Smart. We're going to look at this as our imaginary product and see what it looks like to go through this process. So the first thing is we are going to try to figure out what the minimum viable product is. We can envision all the features we want, and we're going to make sure that we capture them, but also define and organize them into milestones for our product release. So the way we're going to do this is with a product roadmap. So this is a roadmap template that I like to use. It starts out, or the way that I like to start this is to define the problem. So what are the specific issues that a person faces or that an organization faces? They should be relatable and easily understood and communicated. And then once we have a problem, we're going to define what the solution to that problem is. So that's going to be a deliverable. It could be tangible, like a feature, or even something intangible, like we're going to add convenience. And then defining the persona. I think sometimes this can feel cliche, but I find it a very valuable to maintain focus on who you're building this for. So I really like to give a description of an imaginary person that's experiencing this problem, maybe even give some backstory to where they're coming from. And then we need a goal. And so this is some measurable outcome of the solution. It can be qualitative, like brand trust, or it can be quantitative, like a 4.5 average review in the App Store. So roadmaps should be universally understandable. They're a tool that we can use to communicate all the way down to development team to keep them focused, all the way back up to our executives and stakeholders. And we're going to sort these things into kind of a now, next, later timeline. This can be built upon to say, okay, we want this to be quarterly, et cetera. But I think starting out with that simple, like, what do we need to do now? What can we push off? And then once we have all of these, the problems, the solution, the goals, the persona, then we can actually start to get into the feature development and move around the milestones. So let's try to do this with our connected pour-over coffee maker. So our problem, it's a labor-intensive process to make a good cup of coffee. The solution is we can offer customized brewing parameters in this coffee machine so that you can create a cup just the way you like it. And so I'll be the discerning coffee drinker persona here. And what we want is 5-star product reviews on average. So we're going to take that problem and create a theme. And so in this case, the theme that we're going for is just customization. And in order to do that, we have these feature sets. We need to be able to select the temperature of our water. We need to select the amount of coffee grinds that we're putting into each cup. And then also customize when that water gets poured over those grounds in the same way that a barista might do that when they're doing a pour over. And then we can go more into detail about exactly what we want. So for temperature and grind, initially, we're just going to be able to select from a predefined range. And then for the water flow, maybe we just offer a couple simple options, like you can pulse pour it, or you can have a slow trickle of continuous flow. That's enough to get us to this minimum viable product. Like that, these are the things that you need in order to make a pour over. We can expand upon that and then say, okay, well, now within these themes, maybe I want to be able to reorder filters, or I want to offer presets, potentially customize the grind coarseness. Maybe I like a finer one or a coarser one, and then again have presets there. And then for the water flow, rather than just offer these couple options, maybe we want like full customization of the pour and how much water happens at every stage of the brewing, and then profiles so that I can make a cup of coffee the way I like it, and then my partner can make one the way that she likes it. So that might get us to say, well, we have our minimum viable product. Now we have our 1.0 release. This is what we're targeting for launch. But if we just had this, it's still totally acceptable. All right. So moving on to think about how we actually develop these features, I think a lot of times this is what comes to people's mind. There's this cloud component that we need. There's embedded firmware development in order to control all these sensors, the pumps, the motor controller for the grinder. And then there's going to be some mobile app probably for here that's going to allow me to set my custom brew preferences and communicate either over Wi-Fi or BLE to that new device. However, this pie, I think, does not represent the whole picture of what we actually need to be successful here. It looks something more like this, where you have embedded mobile and cloud development is a large chunk of the effort, but there you will also need support and maintenance tools, fleet management, the ability to release OTAs, and then support portals potentially where people can get an FAQ on what's going wrong, or if you have a call center somewhere that people can actually maybe see what's going on with someone's device by looking up their user account, etc. And then there's this whole hardware component that has to happen in tandem with all these things in order for it to be a thing, right? So a lot of planning. And the process that we go through at Spindance to make sure that we're covering all these bases is a system design. So we have our roadmap. Now we can start moving into actually designing these things. This is always a phase that we do that prefaces development. And so I'm just going to go through like a handful of the processes that would be involved in a system design like this. High-level component architecture. This is a pretty basic diagram of what you need in order to have a connected device. And then we'll get more detailed into the system architecture. So what are the actual tools and services that we're going to utilize? We need to consider the scale. We might have millions of these devices. So we have this whole serverless architecture. Here is an example of a diagram for AWS. And then there's security. There's a lot of moving parts in IoT, and so anytime you introduce more telemetry or you also introduce more opportunities for bad actors to cause havoc on your devices or to get control of your infrastructure. So then we can move into some of the data engineering. And this is defining all of the ways in which the device might interface with the cloud, with the mobile app. How are we going to roll out over-the-air updates and ensure the right firmware is delivered to the right devices? What are the safety mechanisms that we can put in place to ensure that we won't accidentally break our products with a flawed update? There's been some high-profile cases where this has happened, where an OTA update is released to a device and then it can no longer be connected, and the only solution is to essentially return it or send out a technician to put new firmware on it. So we want to account for all of that. And then now that we have defined what our infrastructure might look like, we need to estimate what our ongoing costs are going to be. AWS is not free and the billing can get really complex. So what is the cost every time we actually release an over-the-air update? Can we estimate the number of requests to an API per user per day? And then how much data do we want to keep in our data lake and cold storage? And what's the cost of that going to be? So we have some custom tools that we've developed to like help estimate these costs, so that before we even start development, we can already start to look at our long-term outlook of what's it going to actually cost us to have this infrastructure on these devices, and how is that going to impact the price that we ultimately need to pay, or do we need some kind of subscription service if the costs are very high? And so at the end of the day, I think the most important deliverable that you can get out of a system design is the development backlog. And so once we have that, we're at a place where we can actually assemble a team and begin our product development. But before we do, it's a good time here to take a step back. We're going to analyze everything that we've learned throughout the process of the system design, look at the backlog to actually estimate the cost, see what resources we have available and the expertise that's necessary in order to actually develop these things and make it a reality. And it's a great time to just reassess the viability, and then also re-estimate what you think the cost of this entire product release will be. So let's fast forward a little bit, and we can skip over the development phase, even though that's usually the most fun part, and say now we've got our connected pour over machine, and we have released it out into the world, and we have a mobile app that allows us to control it in our cloud infrastructure, and customers have started to purchase it and they're excited. And if we remember, our goal here was to get a 5-star average review, but we find that that's not happening. So we launched it, and now we're getting flooded with 1-star reviews. And the primary complaint is the customers are saying that our grinder motor is failing. And when we, our first thought is, oh no, we're going to have to recall all these devices. We're going to get swamped with returns. It's going to be a very, very expensive problem to solve. And as we look into it further and we investigate, we see that there's variation in the parts being used at the manufacturing facility, and that's what's causing these motor failures. So this brings us to that kind of final beauty of IoT and these devices. It's that because we put this effort into our system design and planning out how our entire infrastructure would account for these problems ahead of time, now we can look at our fleet of devices, and we'll have metrics that have been reported from them that we've stored in a data lake. And so we can go and say, well, what's causing these motor failures? We know that it's the wrong part, but is it the motor controller algorithm? Is it running too fast, too often? What's the issue? And maybe we really don't even know how to answer that question. But because we have all of this data, we can apply a machine learning algorithm and ask it that question, and hopefully get out a viable answer. And then we can take that and turn back to our embedded development team and say, is there a way that we can update this algorithm for the motor that would prevent these failures from happening? At that point, we can test it in our lab, and then we can actually roll out an over-the-air update that remedies this issue. So because we had connected products, now we've just saved our entire product launch, and we've stopped the bleeding from the negative reviews, and we're way back on track towards meeting our primary goal, which was to have a 5-star quality product that can make me a pour over without 10 minutes every morning. So that's the summary that I wanted to offer. I think in closing, there's so many complexities with IoT, and it opens up a lot of opportunities for failure, and there's a tremendous amount of coordination that has to be done across many different domains in order to actually get to that successful launch. But at the same time, it opens up a lot of opportunities, not all of which are obvious. And so it's an exciting journey. I hope that this has been valuable to y'all, and feel free to reach out to Spindance or to me directly with any questions. I think we're going to do a Q&A session now, and I'll turn it back over to Max to facilitate that.
Oh, thanks, Jonathan. It's time for our Q&A session, as you say. We've got all sorts of questions. I'm eager to hear what your thoughts are on them. The first one is, well, this one's how long is a piece of string? How do you determine the team size and the makeup?
Generally, how this works is once we have that system design process and we have a backlog, then we can look and say, okay, what's our release timeline? What's the effort for each of the domains, for cloud, for embedded, for mobile apps, for web development? And usually a team consists of, like, say, 2 to 3 developers within each of those domains for a product that needs all 3. But depending on the complexity or what's already available that we can use off the shelf, it might be less than that.
Okay. So regarding metrics data from field installation in industry, how do we deal with calibration? Is it from the edge or from the cloud application?
Can you elaborate on that a little bit more?
Well, it's not my question, so no.
Yeah, the person who asked.
Okay, I'll ask.
I'm curious what they mean by calibration.
Okay, well, let's ask the guy who posted that question.
Yeah.
If you could elaborate just a little bit there. And meanwhile, we'll continue on. How do you, this is a good one. How do you coordinate hardware and software timelines?
Yeah, it's challenging. One of the things that I think is really important is to prototype the hardware as soon as possible. So even though you might have custom development boards coming from Infineon or some other supplier, take what you can get that mimics it as close as possible and mock up your hardware, so that you unleash the software development team to start testing on some actual device. And then beyond that, like, we create a lot of device simulators, and so we essentially like emulate these devices in software so that it doesn't block our dev teams. And then there's just a lot of coordination with manufacturing, with the hardware teams, to make sure that they're tracking in line with what's happening with the development team for the software.
Mm-hmm. Okay, we're still waiting for an expansion there. Another visitor has said, I understand starting with an MVP, but how do you make sure you're validating through the whole process before you invest and build?
That's a good question. The tools that we utilize a lot are market research, focus groups. So actually, as soon as you have even a prototype device, you can start inviting your users, or a selection of your users that represent the persona that you've defined, and actually put things in front of them and test it out and get feedback. And that may force you to circle back and update your roadmap and change what MVP is, or move features around based off of the feedback that you get. But I really like this idea for product development that says, fail fast. and so that is the validation of your MVP is get as much of a product out there as fast as you can, for the least amount of cost and investment, and then use that real world feedback to inform the future decisions that you're going to make. And with IoT, you can collect a lot of data from the products that are out in the field, and use that feedback as well to continue tweaking your roadmap. That's, always a living document.
Failing fast is what I do best, to be honest. One of my problems is over-engineering everything. Yeah, it's all right to start saying we're talking about an MVP, but then I think, well, wouldn't it be handy if it did this and if it did that? And before long, we've got a specification for holographic interface that we're never going to build in our lifetime. So I think that's another thing. MVP obviously is one end of the scale, but stop product creep. Sometimes you can add too many things to the extent that the user can no longer make a decision anymore because there's so many options.
Right. Yeah. One of the things I like about the road mapping process is that it allows for that creativity and that, taking in this, I've got an idea and someone else has an idea, and there's all of these possibilities of what a product can be, and you can accept them and put them onto the roadmap, but you're still splitting this into milestones of what that you must do now in order to create value.
Right. So we've got some feedback. What we're talking about regarding the metrics data and field installation in industry. How do you deal with data collected from sensors in milliamps and volts into readable numbers like measuring water levels or temperatures? So I guess that's the calibration we're talking about. And do you do that at the edge, or do you do it from the cloud?
Yeah. Well, I mean, I think that would be within the embedded development because there's an algorithm, but we have a kind of custom metrics telemetry process that we use, that allows us to get a lot of data from the devices, for the least amount of cost. And so I think that while that sounds like it would be an embedded systems algorithm for this product, you could still, in your data lake, basically look at the effectiveness of that algorithm, and then potentially tweak or improve it over time, and then release over-the-air updates with improved embedded algorithms that actually run on the devices themselves. So
okay, this is an interesting question. Sort of when you're reading from the sensors and you're getting millivolts and things, comparing, converting those into real world values. But I mean, that's all part of whatever you're doing, I suppose. You start off, what the sensor range is, what the tolerance is.
yeah, and it depends on the way you're sourcing the sensor. I mean, like, some manufacturers and suppliers are going to provide you those algorithms along with their sensor. Some are not, and that's going to be a big lift for the embedded team to basically figure that out from scratch.
But then I think the question here is about calibration, that once it's actually in there, in the industrial environment, and you've set it all up, the fine tuning to make sure that 2 volts actually does equal 10 feet of water pressure or something.
Right. Yeah, I would assume that this would start out in the lab, when you're doing the product development. But again, I think what's unique and special. I mean, that's a problem with like any any physical product that uses sensors or electronics.
The fine
But
tuning would have to be done in the field on an instance specific basis, really.
I guess it depends on the predictability of your hardware.
Hmm.
But I think, you know, I don't know that it would have to be done on the field because realistically, like you can report all of the sensor data, that anything that you can collect, you can report, and then run algorithms off of your entire fleet to determine how these sensors are actually differentiating, or whether they're you're seeing, you know, similar results across all your products.
Hmm. Well, actually, speaking about that, there's another question here. How do you coordinate between embedded, cloud, mobile, and web teams? They're sort of related.
So at the way that the projects that I've been a part of have been run is that the embedded cloud mobile web teams are actually all run as one single team. And so as the product owner, I lead all of those like individual domains, but we share the same agile scrum ceremonies. There's a lot of cross communication. So rather than try to just like isolate these domains and design it so that the embedded team's going to provide a system interface that then the cloud team's going to take, all of that design is actually happening together as the same group.
Well,
I found
certainly,
that to be very effective.
well, you mentioned agile, and we have a question here. Are you using an agile methodology during the development of the MVP?
Yes. We run kind of a typical 2-week agile scrum process. And like I said, that's with all domains involved on a single team. I will sometimes split out backlog refinement just amongst the domains, or with people, for depending on what special skill sets are required. But for the most part, it's one big agile scrum team.
Okay. I don't think we've asked this one. I'm losing track. I understand starting with the MVP, but how do you make sure you're validating throughout the whole process before you invest and build?
I think we did answer
Did you do that?
question already. Yeah.
Oh,
Sorry.
sorry, I've got the questions coming in random order here. What's your approach for dealing with dependencies and concurrencies? I found other departments can put up walls simply by announcing dependency roadblocks.
I'm in a fortunate position at Spindance where we, you know, I work with larger organizations that have a lot of roadblocks across departments. But because we are kind of building our team up from the ground, it's a lot lighter and more agile. I definitely empathize and have experienced problems, especially with like hardware dependencies, where things can be held up. But I would again turn to say, you can usually see that those blockers are coming, and you can identify them in advance, and you can create contingency plans to say, well, if we don't have the hardware by this point, or if this team has not completed this piece of development that we expect to be done, how do we proceed with the rest of the team? And that's kind of the beauty of the agile process, is that you can you know, shelve a feature that's blocked and immediately move on to these other ones. And the worst case scenario is sometimes you just have to pause development until that roadblock is clear.
Is there any guide showing the best protocols to adopt per application or scenario? And the two examples are MQTT or HTTPS or anything else?
I think it's use case dependent. So MQTT is generally the choice for telemetry coming from the device to the cloud, but then you also will need to use HTTPS to maybe download your OTA update, etc. In our embedded systems, we definitely support both on almost every project, but it's what you're trying to do is going to inform which protocol you want to use.
Okay. What tags naming convention are you using?
So ask again.
What tags naming convention are you using?
What tags naming convention?
TAGS.
I'm not familiar.
Okay, well, let's ask the questioner if you could expand on that question a little bit. I was wondering about security myself. What are some of the strategies that you use to ensure devices are secure?
That's a big topic.
Well, in the follow-on, do these strategies translate to industrial IoT?
Yeah, so certificate authorities. The term that I use is we create a device stamp, and so before you even put the firmware on it, you're essentially creating a certificate for the device that is signed by a root certificate authority. It gets stamped onto that firmware, and then depending on the microchip that you're using, there's usually some type of secure boot process where it can like burn e-fuses so that can never be updated or changed again. And then as part of the provisioning process, we'll utilize that cert to verify a few things. Like one, before we even let a user like send Wi-Fi credentials or try to get this device online, we can already say, okay, does this device have the right cert? Is it a genuine device from my organization? Has all of this happened within the same session from between the like API calls to validate the device to the BLE communication to get that certificate off. So that's a big part of it. Encrypted OTA updates, ensuring that you can, in the same way you have this cert on the device that can, so that only your devices can even decrypt your firmware images that you're sending. And then obviously there's well-established patterns for validating those devices when they connect to like IoT Core or Azure. But I think for threat management with IoT, one of the you can kind of break it down and say, okay, where are the attack vectors that are at risk to you? And so you have the physical device itself. Could someone plug a USB cable into it and then try to do something nefarious? And then beyond that, what I like to look at is everywhere that data moves. So anytime you have like a mobile or a web application that's talking to the cloud and there's information in flight, you want to ensure that all of that is locked down.
Right. The person who asked the question, what tags naming convention are you using, has also come back and said, are you getting enough use cases from your client? And I'm thinking that maybe this is tags associated with machine learning type, artificial intelligence, machine learning, where you tag your data.
Gotcha. I am not the right person to ask that question, but we do have some machine learning experts at Spindance that I'm sure would be super happy to field that one.
Actually, we've got a follow-up. Under tag, I mean data flow. For example, from the PLC of the machine, there are different methods to name tags in order to have them have it in a source of data. But like I say, maybe that's something to take offline.
Yeah, I'm not sure that that I'm the right person to answer that.
Well, actually, we've got another question that you may or may not want to answer, but if not, we could do that offline as well after the talk. Someone from Indonesia is saying, do you have any experience with the IoT with active or passive RFID for tracking or asset management? And also, can you give me some explanation?
I know at Spindance we have done some projects for asset tracking. I have not been involved with any of those specifically, though.
Okay. How do you handle cybersecurity? Do you train your team? So I think this is, well, do you train your team? What implementations are to be implemented in your software and hardware? I think maybe you already covered that to some extent. How do you train your team?
Yeah, I mean, yeah, cybersecurity is I don't think you can just like train once, like every software engineer should have knowledge of the threat vectors that they're working within. It just comes with the territory. But I think, you know, another important aspect is you want engineers that know what they're looking for. You want like everybody involved to be thinking about cybersecurity from the ground up. But then again, before you would actually go to market, you would have like we get third-party firms to essentially audit all of the infrastructure that weren't actually involved with the development process. So there's no cognitive bias there.
I think that's a good advice. And there's also now, in addition to cybersecurity, a drive for cyber resiliency, saying that if the system is attacked, it can defend itself. So if it recognizes that someone is attacking and trying to insert, say, new boot code or something, it can throw it out and reboot from a golden image.
Right. Yeah, we do a lot of on the embedded devices, checking at the boot to make sure that the image is effective. I think I brought this up where there have been some high-profile cases where firmware updates went out, and all of a sudden, what was a microwave is now an air fryer, and and then it also the firmware is looking for a completely different type of like Wi-Fi chip, and so it's got the wrong driver, and so now it can't connect, and it means that also you can't release another firmware update. So we do a lot of like bootloader checks to say, okay, when we boot a new firmware image, can we connect to AWS? And if we can't, after a period of time, then go ahead and roll back to the previous image.
All right. Yeah, I know that. Well, I spent some time with FPGAs, and some of the ones used for root of trust, they have dual or even triple boot. where when a new image comes in, they first of all check it for that it's got the right CRCs and things. Then they decrypt it, load it in, check it again, and if they don't like it, they throw it away and carry on with what they've got.
Yeah, it's something that we definitely take into account in system design.
Oh, here's an interesting one. How do you balance thinking of regulatory compliance and the agile fail-fast product development cycle? Do you wait for a second prototype and solid customer feedback before starting to consider regulatory compliance requirements, or do you take that into account early on?
Yeah, you can't do that. You have to think about regulatory requirements from the onset. Like if you're building a product that needs to be UL board certified, it's highly recommended that you start those conversations before you even start development.
Mm-hmm. Regarding data log or storage for environmental monitoring, is there now I'm not sure about this. Is there a basic algorithm that could address this feature, allowing users from the dashboard to get a log of the data within 1 month or more, and be able to have a graph, for example, the CO2 level in the area to monitor the level of pollution?
Yeah, of course.
I think there's loads of tools for that, right?
Yeah.
So I mean, the sensors are just streaming the data, you're storing it in the cloud. Once it's there,
Yeah,
it's up to you to, however you want to access it and plot it, chart it, analyze it.
Yep, it's probably one of the most common IoT use cases is some sensor out in the field that's reporting back its information being stored in a database, and then that can be visualized or mined to make business intelligence decisions.
And that's where you can start throwing artificial intelligence and machine learning at it to spot anomalies and detect the predictive maintenance, detect when machines are starting to go down and things like that.
Yep.
In relation to device and IoT telco testing, how do you determine what is the QoS, quality of service, and how to measure the real bandwidth to show that connectivity is adequate, even when the RSSI is low?
I mean, depends on the device and the connection method. We by default will report all of this information into the cloud and track it basically, so that like any device in your fleet, you know what the RSSI values are and how its connectivity is, and then if you can create actions to say, like, if it's below this, then go ahead and alert the end user that their connectivity is unstable and they should repair their network or relocate their devices.
Okay. I think we've got time for one last question. And while we ask this question, Jonathan's told me that you can feel free to contact him directly using the contact details that will be shown on your screen. So actually, this one plays right into your hands, Jonathan. Is there an advantage to owning a custom IoT platform versus using a third-party vendor?
I think so. There's pros and cons. The third-party vendors usually will charge per device with ongoing fees to utilize their platform, and so that's the lack of control over the cost of the infrastructure is obviously a disadvantage. And then the other is just the lack of control over what the infrastructure can do. The third-party vendors might be the right solution for some products, but at the end of the day, then you're at the mercy of their backlog instead of yours.
And I think when you started the presentation, you were talking about creating the coffee machine product. And because this was a presentation that just covered one product, you sort of think of bringing everyone together for that one product. But in reality, then you're going to do another product. And when you do the second product, you already have a lot of this expertise, and things will presumably go an awful lot faster.
Right. So that's the beauty of like an IoT platform development, is that the designing for flexibility aspect of this is, yeah, we just did the one example of the smart coffee maker, but you may release an entire collection of devices that all utilize the same patterns and the same IoT platform, potentially with variations in the data that they're reporting or the actions that can be taken. But as much as possible, you want to share and reuse that infrastructure, and not recreate the wheel for solid patterns that have been tested and proven.
All right. Well, we've got a lot of questions that remain unanswered at the moment, but we want to be mindful of everyone's time and finish on the hour as we promised. So Jonathan has said that he will contact anyone directly. Any questions we've not answered, Jonathan will get in touch with the questioner via email, the email you used to register for the conference. And again, if you've got any follow-up questions later on, you can contact Jonathan directly. So this brings today's webinar to a close. And I'd like to thank everyone for attending, especially to Jonathan for his insightful presentation. Once again, this is Clive Maxfield. From all of us here at IoT Central, we hope you have a wonderful rest of your day.